We continue with Model 3, sample project underscore BR without delay. And we go right back to the risk register, where we see there is now quite a comprehensive risk register, including numerous identified risks and all the unknowns that we have assessed. But there's one thing missing. We call this whole model integrated cost and schedule analysis, but we have not yet integrated the schedule results into our risk register. So we make a new folder called delay cost. Before we quantify that, let's go back to the workbook schedule and have a look at the schedule results. We have a base schedule plus uncertainties, and base plus risk schedule, where all the tasks, or most of the tasks, have risks assigned to them, which is shown by the colored extensions here. Purple are tender risks, orange are owner's risks, and green are contractor's risks. And taking all of these risks into account, our Monte Carlo simulation will give us a distribution function for the construction completion date. And in this case, that's the result. Our construction completion will be between May 2024 and March 2025. Now, there's one more thing that we would like to know, and that is how many days of delay are caused by owner's risks. To find that out, we go to this tab and click on owner and find it's 5.6 to 21.6 months. And this will be the basis for the calculation of our time-dependent cost. So let's go back to risk register, create a new cost element, identified risk. It's called delay cost. For the quantity, we connect the schedule results. So we go to the construction completion milestone and select owner so that we only catch the risks caused by the owner. And this is now our quantity. And we put a price tag to it. So we say it's about 250,000 daily cost for each day, up to 400,000 or maybe as low as 150,000. And we simulate that, and that's our delay cost. At this point, I would like to switch right into Model 04. So we go to Workbook Open, do not change, go to Model 04, go back to the risk register, because we have here prepared a little more detailed assessment of the delay cost. We have divided that into 4 different cost elements, the first one being owner's cost, $15,000 per day for his own stuff, his designers, his consultants, and so on. Then we have the claim, the contractor's claim, contractor's cost, which will be about $250,000 per day at this big construction site. Then we have the contractor's liquidated damages, which is the money we get back from the contractor due to delay caused by himself. And then there are economic losses, which in many projects is not assessed, but can be assessed if you want. That is the economic cost of your delayed tunnel opening, for example. All in all, the delay costs are in this project between 96 and 262 million euros. The P50 value is 171 million US dollars. So that is quite a significant amount and should be taken into account in your risk analysis. After connecting our schedule model to the risk cost, we have completed our risk assessment. We have also completed our base cost estimate and our schedule model, so there's just one thing missing, which is escalation. Let's go back to the workbook sample project tunnel, and let's go to construction contract, add a new group, which we call escalation. We will also put a code in there and assign a color. Escalation is purple, and then right click And instead of new cost element, this time we select new escalation element. Select the right cost component, which is E in this case, and press OK. The name of this element is just escalation, or you could call it escalation construction contract. And then we want to create new subcomponent with escalation items. Press this icon, select the right group, which in this case is construction contract, and select BR, because if you remember the cost component structure, the basis for our escalation calculation is the sum of base cost and risk. So this is what we want to select. Now there are 3 different methods to calculate the escalation. If you have questions about these, just contact us. For now, we will select Monte Carlo and select an annual price increase rate with a minimum of 0%, most likely value 2%, and maximum value of 7.5%. We pass that on to the other years, and we can now calculate our escalation. But before we do that, we need to assign a cash flow for the construction contract because we have not yet defined when we are going to spend our money. So we go to construction contract, we go to temporal outflow, select BR, select the years where we want to spend our money, which is 2020 to 2023. Then select the predefined distribution or put in the percentages to your liking, and then pass it on to all the cost elements in the group construction contract. We have now a cash flow. You can also look at it in a stacked version: base cost, identified risk, unknown risk, and we can go back to our escalation element. If you look at these numbers here, they were all 0 before. We have now assigned a cash flow in the year 2020, 2021, 2022, and 2023. Combined with the annual price increase, we get an escalation that is between 104 million and 161 million. So with base cost, risk, and escalation at hand, schedule and cost model connected, we have completed the integrated cost and schedule analysis and can switch to our final model where we look at some of the results.